Hello everyone, Mr. Schultz here. Welcome to Integrated Math 1. We're talking about Notes 9.5, Distributions of Data. So don't forget to put your first and last name up here, as well as your period number. Oh, it jumped a little bit. So we're going to talk about distribution. A distribution is where we have a graph or a table that shows how data has been doled out. So for example, we could have some like a bar graph, and we can see that, hey, look, it looks like this. It's like if we look at probability, it's most of the stuff's going to be in the middle, and it's going to be kind of have a centered thing like that. Now, what this would look like is we look, hey, look, we could have a box and whisker plot like this. And so we could see that this is, once again, it's like it's evenly distributed. Or we could have like a dot plot where this is evenly distributed out. So those are all examples of how, the data has been doled out or distributed out. All right, let's go on. So a graph could be negatively skewed. So this means, it's going to lean one way or another. So this means that there's fewer data on the left. So that looks like this. So we could have something where this bar graph or histogram is going to, it looks like it's huge on the right. It has a lot on the right, and then when you get to the left, there's a little tail. Like here's the head, here's the tail. Or when it looks like this, we could have something like where the box plot looks like this, and then it comes out this way. So it's most of the data is going to be on the right, because there's fewer data on the left. Now we could also have something that is positively skewed. Distribution. And so this is where fewer data is going to be on the right. And so this would look like the opposite. So give me a second on there. So on this, most of the data is going to be on the left side. And then you have for this, you have the big head right there and then tail going this way. For this one, it's like, hey, look, 50% of the data is to the left of these lines I just drew right here. 50% is this way. So most of the data is right here. It's like it's leaning one way. Fewer data is over here. All right, let's go on. So here are some links. Here's a Desmos histogram. That's blank. You can go ahead and fill it in. And here's a box plot example on Desmos. Go ahead and look at that when we get to that. So you're going to need a graphing calculator eventually in high school. If you're going to get into, after Integrated Math 2, you will need a graphing calculator. But for now, you can use for some free emulators or browser-based computers on Desmos. So let's write that in, desmos.com. Next up, that's page 1. Let's continue. So what we're going to do is we're going to analyze the distribution by using technology. So we're going to plug in this information to figure out what does this histogram look like. So go ahead and click that, and then I'm going to show you. Click the link on the histogram in 3, 2, 1. All right, so looking at this, what you're going to do, it doesn't matter about the left side. But on the right side, you're going to fill in all the data, all the bits of information you received. Now, if you look, you should get 16 of them. Now, going down, you will need to change the number of pins or bars in your histogram. Because if it looks a little different, go back there. If you change it a little, it's going to look a little different. Now, actually, if you make it too big, it's going to, or too many, it's going to not look like anything. So we want to change it in order to get a good shape. So for example, it says pick 7 to 10. Looking at this, this is approximately what this one is approximately what it should look like. Now, it's like a rough sketch on here. Now, if you actually had a graphing calculator, it'd be wonderful, but we don't live in that luxury. So let's continue. If we plugged all this information, here is our histogram. Now, what else do we need to do now? Well, if you look right above here, there's a little arrow that says share graph. Go ahead and click that. You're going to see export an image. Go ahead and you can download it. And then what I do is I look at it and I right click and I push copy. After that, I go straight back over here. Oh, I have a random B in there. And then I can paste it. So let's see if I got paste. So let me see. So I don't have a paste, but what I could do is I could save it onto Google Drive and then take it from Google Drive and place it in here. So I'm going to do that right now. So I click my drive and then images and videos. I named it, I know it's Desmos, so I find it right here and then I can click it, select it, and boom, I can click and drop it right here. Easy as just copy and pasting, bam, there we go. So going on, we can do the same thing as making a box plot. So what we're going to have to do is we're going to have to copy the data and then bring it on over. So hold up. So if we bring the data over here, all we have to do is now paste it. All right, so what we're going to do is we're going to create the brackets. We're going to say, hey, we're making a list. We're going to have brackets and we're going to put the data inside and bam. All we need to do is say, hey, here's a list. Put the list. Say, hey, I want to make a box plot out of it. And then, once again, copy, paste, bring it back in. Well, actually for you guys are going to have to save it to your Google Drive and then pull it in. I can do the copy paste thing, but that's on me. All right, guys, so let's go on with our information in 3, 2, 1. All right, so looking at this, I'd probably want to resize it, make it a little bit bigger since I have some more space. I look at this. Here's my histogram. Here's my box plot. You can make your box plots pretty easily using that list, but the histogram, you'll probably want to use that histogram Desmos link and redo that every single time. All right, let's go on, guys. Example 2, use appropriate statistics by using a histogram or, box plot. It doesn't really matter because we can get the data from Desmos. All right, so what we're going to do is I'm going to use this data and we're going to figure out what is the mean, standard deviation, maximum, minimum. Ooh, I have two maximums. Let's delete one of those and make it or let's cross out one of those and make it a minimum. All right, the median, the lower quartile, and the upper quartile. So I'm not going to write it in, but you will. So let's go on in 3, 2, 1. All right, so if we are in Desmos and we have our list and we say, hey, we want to make it a box plot, we can continue with that. We don't even need the box plot, but it's nice to have it. We can create some, I guess you could say, programming. We're saying, hey, we want to know this. So the mean of list L, or the mean of L, because we're saying L is this list, it will tell us 16.375. STDEV stands for, in parentheses L, stands for the standard deviation of list L right here, or L, which is the list. Max, L is the maximum. The minimum of L, for the min L for minimum. And don't forget to make sure you write down these numbers in the far right-hand column. Going on in 3, 2, 1. All right, so now we're going to talk about the quartiles. We have the median, or quartile number 2. So basically we're saying, hey, On this element right, this L, list, L, what is the quartile number 2 or the median? It's 17. About quartile 1 and 3, 11.5, 21.5. The program will do the work for you. So let it do it for you. Plug in the data, let the calculator do it. All right, going on in 3, 2, 1. All right, so hopefully guys wrote in that data right here. And so now we're going to about learning extreme data points. So, drawing tool now. The least and the greatest values in a set of data are called extreme values. If a value is more than 1.5 times the interquartile range, above or below the closest quartile, it is considered an outlier. All right. So let's go on in 3, 2, 1. Now, here's like the basic of it. An outlier is something that is far away, that skews the data, either making it seem bigger or smaller. Remember those zeros on a test? Because they didn't take it, it brought the average score down, but the average score was like a B minus. But because of those people who didn't take it, it brought the average down to a C. So that's kind of, these outliers change the data drastically. All right, let's do our last example and go on. So example 4, choose appropriate statistics with extreme data points. Okay, so I'm going to have you guys follow along with me. Sharks, the lengths and feet of adult sharks in various species are shown. Describe the center and spread of the data using appropriate statistics and identify the effect of extreme data points. Okay, so here's all this data. What are we going to do? Well, the first thing I'm going to do is I'm going to highlight all this, and then I'm going to put it into my calculator, my Desmos calculator. So I go over here, I can delete this, and I can put the new data. So, looking at this, I can now figure out what is my information. So looking at this, I know my mean. It tells me all this information right here. So I'm going to let you guys look at this for a second, and then we're going to go with the data. So it looks like the mean, go ahead and write this in. It looks like the mean is 13.815. It looks like the standard deviation is about 10.9. The maximum is 46. The minimum is 0.6. Now quartile, the median, the middle number, is 12. Quartile 1 is going to be 5.85, and quartile 3 is 19. Now you need to write that information down. I'm going to take those last 2 bits of data right there. So let's go on in 3, 2, 1. So it looks like the lowest one was 5.8, 5.85, 5.85. And it looks like the upper quartile was 19. So if I subtract those out, I get 13.15. All right, so now on your calculator, or using your knowledge, we're going to have to see, is the distance 46, is it greater or equal to 13.15 times 1.5, the distance from here to here? Let's see. Let's subtract by 19, and we get 26, 27. So the distance between the extreme and the third quartile is 27 units. Is this bigger or smaller? Well, it's bigger. So that means this 46 is an outlier. So if we look at it, we can click, hey, we want to hide outliers. And so now look, it'll show us that outlier as a little circle, a little point, and we'll exclude it from the data, and it changes it. All right, guys. That's it for notes for 9.5. Make sure you use this effectively and wisely because tools do exactly what you want them to do as long as you understand what it is you are asking it to do. All right, guys, have a great day, and I'll catch you guys in class. Bye.